So this is an example from the Khan Academy exercise, graphing solutions to two variable linear equations. And they tell us to complete the table so each row represents a solution of the following equation. And they give us the equation, and then they want us to figure out what does y equal when x is equal to -5, and what does x equal when y is equal to 8. And to figure this out, I've actually copied and pasted this part of the problem onto my scratch pad. So let me get that out. And so this is the exact same problem. There's a couple of ways that we could try to tackle it. One way is you could try to simplify this more, get all your x's on one side and all your y's on the other side. Or we could just literally substitute when x equals -5, what must y equal? And actually, let me do it the second way first. So if we take this equation and we substitute x with -5, what do we get? We get -3 times, well, we're going to say x is -5 times -5 plus 7y is equal to 5 times x is, once again, it's going to be -5. X is -5. 5 times -5 plus 2y. See, -3 times -5 is +15 plus 7y is equal to -25 plus 2y. And now to solve for y, let's see, I could subtract 2y from both sides so that I get rid of the 2y here on the right. So let me subtract 2y from both sides. And then if I want all my constants on the right-hand side, I can subtract 15 from both sides. So let me subtract 15 from both sides. And I am going to be left with 15 minus 15, that's 0. That's the whole point of subtracting 15 from both sides. So I get rid of this 15 here. 7y minus 2y. 7 of something minus 2 of that same something is going to be 5 of that something. It's going to be equal to 5y is equal to -25 minus 15. Well, that's going to be -40. And then 2y minus 2y, well, that's just going to be 0. That was the whole point of subtracting 2y from both sides. So you have 5 times y is equal to -40. Or if we divide both sides by 5, we would get y is equal to -8. So when x is equal to -5, y is equal to -8. Y is equal to -8. And actually, we can fill that in. So this y is going to be equal to -8. And now we got to figure this out. What does x equal when y is +8? Well, we can go back to our scratch pad here. And now let's take the same equation, but let's make y equal to +8. So you have -3x plus 7. Now y is going to be 8. Y is 8. 7 times 8 is equal to 5 times x plus 2 times, once again, y is 8. 2 times 8. So we get -3x plus 56, that's 56, is equal to 5x plus 16. Now, if we want to get all of our constants on one side and of all of our x terms on the other side, well, what could we do? Let's see, we could add 3x to both sides. That would get rid of all of the x's on this side and put them all on this side. So we're going to add 3x to both sides. And let's see, if we want to get all the constants on the left-hand side, we'd want to get rid of the 16. So we could subtract 16 from the right-hand side. If we do it from the right, we're going to have to do it from the left as well. And we're going to be left with, these cancel out. 56 minus 16 is +40. And then, let's see, 16 minus 16 is 0. 5x plus 3x is equal to 8x. We get 8x is equal to 40. We could divide both sides by 8. And we get 5 is equal to x. So this right over here is going to be equal to 5. So let's go back. Let's go back now. So when y is +8, x is +5. Now they ask us, use your two solutions to graph the equation. So let's see if we can do, let me use my mouse now. So to graph the equation, so when x is -5, y is -8. So the point -5, -8. So that's right over there. Actually, let me move my browser up so you can see that. -5, when x is -5, y is -8. And when x is +5, and we see that up here, when x is +5, y is +8. When x is +5, y is positive 8. And we're done. We could check our answer if we like. And we got it right. Now, I said there was two ways to tackle it. I kind of just did it, I guess you could say, the naive way. I just substituted negative 5 directly into this and solved for y. And then I substituted y equals positive 8 directly into this and then solved for x. Another way that I could have done it, that actually probably would have been, or it for sure would have been the easier way to do it, is ahead of time to try to simplify this expression. So what I could have done right from the get-go is said, hey, let's put all my x's on one side and all my y's on the other side. So this is negative 3x plus 7y is equal to 5x plus 2y. And let's say I want to get all my y's on the left and all my x's on the right. So I don't want this negative 3x on the left, so I'd want to add 3x. Adding 3x would cancel this out, but I can't just do it on the left-hand side. I have to do it on the right-hand side as well. And then if I want to get rid of this 2y on the right, I could subtract 2y from the right, but of course I'd also want to do it from the left. And then what am I left with? So negative 3x plus 3x is 0. 7y minus 2y is 5y. And then I have 5x plus 3x is 8x. 2y minus 2y is 0. And then if I wanted to, I could solve for y. I could divide both sides by 5, and I'd get y is equal to 8/5 x. So this right over here represents the same exact equation as this over here. It's just written in a different way. All of the x, y pairs that satisfy this would satisfy this and vice versa. And this is much easier because if x is now negative 5, if x is negative 5, y would be 8/5 times negative 5. Well, that's going to be negative 8. And when y is equal to 8, well, you actually could even do this up here. You could say 5 times 8 is equal to 8x. And then you could see, well, 5 times 8 is the same thing as 8 times 5. So x would be equal to 5. So I think this would actually have been a simpler way to do it. You see it all. I was able to do the entire problem in this little white space here instead of having to do all of this slightly hairier algebra.